And we are live. Hello, Martyn.
Hey, how are you?
I'm good. So we're gonna talk about the Azure Service Bus. Just before we do, I would like to ask you, who you are and what you do, and so on and so forth.
Yeah, sure. So I'll try and be brief, so we can get through the content. But so you probably tell by the accent, I work out of the UK, but actually for a US company. I'm actually due to move over to the US, but the pandemic had other ideas. So until that clears up and is in a better situation, I work US hours, but in the UK. I work for a managed service provider called Insono. One of their unique value propositions is that they do everything all the way from mainframe all the way up to public cloud. So they do mainframe, private cloud, public cloud, hybrid cloud, everything in the middle. Me specifically, I sit within the Azure team. I'm one of the principal technical consultants. So primarily for me, I spend my days doing a lot of stuff like this. I do a lot of community stuff, a lot of user groups, all that kind of thing, a lot of speaking at events. September's been a very busy month for virtual events, actually. But I actually do a lot with our DevOps service as well. So I designed and implemented our DevOps consultancy services at Insono. So my primary technical background is in Azure, not infrastructure services. So although I did start in infrastructure services, my actual background is in software engineering. So I've always been more interested in a lot of the integration components and the developer-based components, all of those kind of things. Yeah, for my sins, I'm a .NET developer by trade, I guess, and that kind of transfers itself pretty nicely into a lot of the cloud native technology, including Service Bus that we're talking about today. And just a last bit on this pretty quickly. Before Insono, so I was actually at Insono last year and left in a completely different role. I went to go work for Virgin Atlantic, the airline out of the UK, so a transatlantic carrier. And again, the pandemic had other ideas about staying there. So I came back, but Virgin Atlantic is quite unique in a lot of their front end systems that you would interact with as a passenger is all based off platform as a service in Azure. So there's a lot of service bus, a lot of messaging technologies in use, a lot of APIs and all kinds of stuff like that. So I'll throw in some examples as we're going through as to where I've used that kind of thing before, because Service Bus, quite honestly, is very easy technology to work with and very easy technology to use. But where I think a lot of people struggle with Service Bus is where would I use Service Bus? And exactly. when I know when to use Service Bus, why would I use Service Bus when there are other tools and options available? So we'll go through a lot of that stuff in this session. We'll make sure slides come up. Okay. Yep. So quite a bit to go through. In all honesty, I'll just move that out of the way. So yeah, as I was saying, Service Bus is quite a straightforward technology to use in a lot of ways, and there's lots of other options available when it comes to Azure, so it can be really confusing, quite honestly, as to when you would use one thing instead of another. And so I want to go through that, and we'll look at some of the messaging services that are available in Azure and talk a little bit about when you would use certain ones in which scenario. I also want to look at the high-level architecture with you as well, so make sure that we understand what namespaces are, queues, subscriptions, how they differ, what they can be used for, and what their I guess what the best way to look at them is from when you're architecting a solution. How do I know whether I need to use a queue or a subscription? All of those kind of things. Really important when it comes to cloud native architecture and cloud native computing as well is how do we optimize performance? So it's really good having these tools that can auto scale and low cost to run, and then you scale them whenever you need to. It's really good stuff. However, you can still end up in a bad situation pretty quickly if you don't design and optimize the performance of your application and your components properly. They can, a lot of components in Azure can obviously exponentially scale, and that can lead you to quite a number of problems later down the line should you get a bill at the end of the month and have an unexpected cost in there that you don't know about. As with every piece of enterprise architecture as well, we have to talk about things like recovery and replication and high availability. And then from an application perspective, just how do you handle outages in some of this technology as well? Because it is the cloud. You know, being completely honest, I don't remember an instance when I've had issues with Service Bus and the service itself has gone down. But fundamentally, it is based on storage, right? It is based on Azure storage. So you do need to be mindful of the thought that it is based on the storage service, and if there is a problem with the storage service, there is likely to be a problem with Service Bus as well. So we'll talk a little bit about how you can handle some of those outages. So I want to look at the three major options when it comes to messaging in Azure, and that is Event Grid, Event Hub, and finally Service Bus. You can use them interchangeably, in all honesty. And the diagram that I've got at the bottom is actually off the documentation rather than recreating my own. It's a Microsoft one, but it shows you a scenario where you might use all three, or you might use a number of those different technologies. So if you look at that diagram before we go into a bit of detail about the three of them, you can see that we would drop a file into a storage account, and then we would capture that file in Event Hub. That Event Hub would then fire an event with event data in, which we could then send over to Event Grid. And then when we capture that data, we then invoke an Azure function app, which would retrieve that file, and then we can migrate that data into a SQL data warehouse in this example. So, you know, there's potentially some extra steps that you might need in there, but the key thing with this really is to show you that even though they do have very specific use cases for various different things, as with a lot of serverless technology, actually, fundamentally, they can be interchangeable and used in one solution as well as being used individually. So that's really important to understand as well. So first of all, from an Event Grid perspective, so Event Grid is, you know, hopefully you can tell by the name, it's an eventing backplane. So it works with any event-driven reactive programming model, basically. It uses a publish subscribe model. So any publishers that emit events but have no expectation about which events are handled, i.e., I don't care what happens on this system, anything is an event. Event Grid is the place to consume those events. So Event Grid is also really deeply integrated with a lot of Azure services. So behind the scenes, a lot of times when you receive events from various different Azure services, even though you can't see, it is actually Event Grid that's retrieving a lot of that information. So it simplifies the consumption of events. It also lowers the cost by eliminating a lot of the need for constant polling. So Event Hub sits there and waits for events to come rather than constantly going out to something and saying, is there anything for me? Is there anything for me? So that's what we mean by polling. So it efficiently and also very reliably would then route events from Azure to also non-Azure based resources as well. So as with a lot of the integration suites in Azure, Event Grid is no different. It will be able to take an event from a system and push that to either an Azure function or an Azure resource, or a non-Azure resource. It could be in your data center. It could even be in AWS or GCP if you wanted. It doesn't really matter where it is. The distribution of these events are done to registered endpoints. So you would, in the case of the example at the bottom there, the diagram, the function app has a published endpoint that is registered in Event Grid. So again, there's no polling. So what's basically happening is the event is coming in and then it is routed out to subscriber endpoints. And in that diagram below, the function app would be a registered subscriber. So the event message then has all of the information that you need to be able to react to changes in your service or your applications. What it is not, however, is a data pipeline. That's what event hubs are for, and we'll come on to event hubs at the minute. So it doesn't deliver the actual object, but it will deliver the changes that happen basically, or the event data around it. So you may have a URI or a path to the original piece of data, but it will not tell you. It will not give you the full object as to what's changed. It will just give you the event-based information. Think of event log in Windows in a lot of ways. The event log has within it data about what has happened, but generally speaking, not the actual data of the component that has failed or has logged the event itself. Delivery is based on a method called ALO, which is called at least once delivery. So that means that the message will always be delivered at least once to an intended target. Okay, so just skipping to the end a little bit for event hubs. So event hubs are big data pipelines. They are there to facilitate the capturing, the retention, and the replay of telemetry and any event stream data. Data can come from concurrent sources, so it can come from SQL servers, it can come from event hubs, it can come from IoT sensors, anything that produces telemetry. As a stream-based processing service, this has the capacity to be able to handle all of that data. You can basically stream data out in a continuous stream. So when it comes in, it goes out the other side. Or you can bundle events into batches itself. So depending on what your application does, you can bundle it into certain batches. So Event Hub is also massively scalable. Right? I've worked with Event Hub before, and we were pumping anywhere between 1 and 1.5 million events a minute through the service. So if you're thinking of using Event Hub to send 1 or 2 messages a day, this is not the architecture for you. It is way too complicated and way too scalable to be dealing with stuff like that. This is why there are multiple messaging services available. So I'm not saying you couldn't do what you wanted to do in Event Hub. Chances are you absolutely can do what you wanted to do in Event Hub. But if you're looking at sending point messages, or you want some more advanced functionality about sending and receiving messages, then this is where Service Bus comes in. So you can akin Service Bus in broad terms to something like RabbitMQ. There's another legacy on-prem messaging platform that has been made cloud native or cloudified in some way by the vendor. But Service Bus is intended for your traditional enterprise applications. So any applications that require transactions, any ordering of messages, any detection of duplicates, instantaneous consistency, this is what Service Bus is good for. So Service Bus lets your cloud native applications provide reliable state transition management for your business processes. So when you're handling high value messages that cannot be lost, cannot be duplicated, this is where you would use Azure Service Bus. It also facilitates secure communication across hybrid cloud solutions as well, and can also connect to on-prem existing systems as well as cloud solutions. There is support there for both a .NET SDK. You can connect via TCP to endpoints as well. And if you use the premium Service Bus offering, you can actually attach that Service Bus namespace onto your private network and give it a private IP address, so it acts and smells like it's just on your network. Service Bus, so therefore fundamentally, it's a brokering messaging system. So it stores messages in a broker. So an example of a broker is a queue until the consuming party at the other end is ready to receive those messages. So those are the 3 big differences. like I say, chances are you could do one specific task that you wanted to in all of these systems, but there are times when it comes to cloud architecture where you will go down a specific technology route because you're trying to achieve something very specific. Okay, so let's just look at some common scenarios first of all when it comes to service buses and architecture. So we talked about messaging first of all, right? So the ability to transfer business data, so things like sales orders, inventory movements, all of those things, those are all great scenarios for using Service Bus. The ability to decouple your applications as well, improving the reliability and the scalability of your applications. So I've put anti-corruption layers in there as well. So anti-corruption layers are a cloud native architecture blueprint where if you have a cloud native system, i.e. system A, and a legacy backend system running on VMs, which would be system B, before that migration to the cloud, they were both based on VMs and talked together absolutely fine. But the migration to cloud native for application A has broken that layer of communication between the two systems. What you can put in the middle is a design pattern called anti-corruption layers, which basically lets one application then talk to the other. So it's almost like you have a system in play that would translate one language to another language. That design pattern for doing that would be called an anti-corruption layer. You are putting a system in the middle that lets you convert from A to B, and that is exactly one of the scenarios that Service Bus would let you employ. So topics and subscriptions is the main way of messaging. So topics and subscriptions, they enable one-to-many relationships between any publishers who send the messages and subscribers or receivers who receive the messages. We can also work on quite specific and quite detailed workflows as well. So we can manage those sessions. So we can dictate the order of messages has to be in a specific order. So I can say that if the messages are sent in order message ID 213, then they will be reordered and consumed 1, 2, 3, so that they're consumed in a specific order. For some systems, that transactional level of ordering is incredibly important. So if you think about, so again, going back to some of my background in aviation, if you think about that process of checking in for a flight and checking in many people for a flight, we may or may not, a bit of insight there, we may or may not post a message from the online check-in system onto a service bus to say that your ticket ID for this flight on this date has picked seat 35A. What we don't want is other people to pick the same seat and have conflicts. So that is an exact scenario of where we would use sessions and we would process on a first in first out scenario. So we make sure that if you pick 35A first, you are the one that gets 35A regardless if 10 people at broadly the same time also request the same seat. So it's really important when it comes to things like that that you have that ability, and that's what Service Bus is really good at. Event hubs and event grids do not give you that level of control when any of your messages require specific ordering or even deferral as well. We may defer a message until another message has been processed. Okay, so let's look at namespaces. So namespaces are at top level. So you may say that containers, a namespace is a container for all of your components within your Service Bus instance. So your namespace can then contain multiple queues, multiple topics, and quite often you would work off a Service Bus namespace per application. So if you had a line of business application that was for doing payroll, for instance, and it needed a messaging service, then you would have one specific Service Bus instance that did that specific workload for you, and that is exactly where this scenario comes in. You can have a maximum of 200 namespaces per subscription. Because it's quite a lot. That is split up into either 100 basic and standard or 100 premium. So you can't have, say, 150 basic or standard and 50 premium. It is a maximum of 100 of each. And the SKUs provide you with varying levels of geo redundancy. So the premium tier has the ability to have a firewall, put it on a private network, and also have it geo redundant to another Azure region as well. And then for anyone connecting via TCP rather than the API, there's a maximum of 1,000 concurrent connections per namespace. So it sounds like a lot, but if you're in a particular application that's quite chatty and has a lot of traffic going backwards and forwards, don't forget that for every sender and receiver you have, that is 2 TCP connections, and that might be part of one transaction. So effectively, you could potentially have 500 concurrent transactions running at once. Obviously, you would hope that you will put some scalability in there to be able to make sure that you deal with that on both sides and have retries in there, so that if the message doesn't send the first time, it would retry and so on and so forth. But that's a hard limit that's quite important to understand, because I've spoke to clients before about Service Bus when I say, you do know if you choose to connect via TCP for some of your on-prem systems, there's a maximum of 1,000 concurrent connections, and every single one of them has gone, oh, that's loads, we'll be absolutely fine. And I can guarantee they come back in a few weeks and say, oh, we're getting a connection timeout error. And I said, oh, you remember a few weeks ago when you said that TCP limit was enough? Well, it seems like it's not. So you have hit the limit. Congratulations. Okay, so let's start to get into the weeds a little bit more about some of these components and some of these services. So queues are basically a way for messages to be sent and then received, right? So you can see at the diagram at the bottom that the sender sends a message into our message queue. It has a number of messages in, and then the receiver at the other side is responsible for processing those messages. So those messages are stored until the application is available at the other end to receive those at the other side. So they are then ordered and timestamped upon arrival. So if ordering is important, make sure that you have some value within there to be able to make sure that the receiver understands the order. Once they are accepted into the Service Bus queue, they are then held in storage until that receiver says, I'm ready for this message, pull it this way. Messages are also delivered in pull mode only. So Service Bus does not push messages out on a queue. It will only deliver them when the receiving application says, send me a message. I'm ready for the message. Send me the message. Okay, so on to topics, and topics are where you can have subscriptions. So again, topics are just like on queues. They are used for sending and receiving messages. Your queue is for point-to-point communications, whereas topics are based in a publish and subscribe scenario. So what does that mean? So first of all, subscriptions are independent of each other. So even if the same message is delivered to 3 receivers, those subscriptions are independent of each other. Those systems that are setting up those subscriptions to look for specific messages are independent. Filters and rules then define the conditions that would trigger some of those actions. So I think it's really a good use case for this is an ordering system. Okay, so when you pay for something in an online checkout and you complete the order, okay, a number of things happen in the back end typically. So it obviously varies per per platform and per team, but generally speaking, if you imagine that one copy of that order goes to you, the customer, one copy of that order goes to the warehouse to be able to dispatch your order, and one copy goes to accounts so they can recognize the revenue that you've just spent, right? So that one order is basically copied 3 times. Best thing I can think of this is when you go into a store and you order something, sometimes you get, 3 sheets of paper and you write on one and it goes through all of them. So you get carbon copies. It's a bit like that. It's a bit like an email when you send carbon copies on emails. We have 3 subscriptions on the end. Your subscription in terms of an email being the email address you are specifically sending it somewhere. They look for those matching criteria and then again, they pull the messages down. and you can set up filters based on a broad level of SQL, which will then define any conditions you want to match, and then that receiver will then pull down any applications. Sorry, any messages that are then defined at the other side. Okay, so there's some of the basics there, right? There's quite a bit more in a lot of times to Service Bus, but that is fundamentally it. There are quite a lot of advanced features. So messaging sessions, we've talked about a little bit. So this is where we talk about first in, first out guarantees. This is where we'd use sessions. So when you send a message that needs a session, you would give it a unique GUID, and that GUID must then be used for subsequent messages, and that GUID is your session ID, effectively. So like when you browse a website that uses cookies and uses sessions to maintain state between pages, they use sessions. It works in exactly the same way. You have a unique session ID for your session, you store data, or in our case, you put messages into the service bus for that session. And then at the other end, something processes that message, and it may want to send a message back. So this is where we can start to crisscross messages. This is exactly what sessions can be used for. So messaging sessions can enable joint and ordered handling of any unbounded sequences relating to those messages. But what they can also do is, if you have system A and B and service bus in the middle, system A could say, and again, we'll use the ordering scenario. I've placed an order. At the back end, there is a receiver that says, I can see your order, I can see some card details in there. Let me try processing the payment. It processes the payment, and then it sends a message back onto the service bus with the same session ID saying, yes, that payment was successful. And if you imagine your front end on the other side receiving that message back saying it's successful, they can then send you an item in the GUI to then say, look, this is now successfully paid. I'm going to show you something on the screen that's got a nice green tick on it and says, okay, we're now in a good place. Auto forwarding is another interesting feature. So this is a way to chain a queue or subscription to another queue or topic, right? So they have to be within the same namespace, but with auto forwarding, the service bus automatically removes messages from a queue or subscription and then will put them in a different queue or topic. So if you want to daisy chain, this is effectively what this is. If you want to send a message from A to B and then have B sent to C, auto forwarding is the feature that will enable you to do that. Okay, dead letter queues or DLQs. So dead letter queuing is very, very important. So a DLQ will hold a message that can't be delivered to any receiver. When you put a message on a service bus in either a queue or a topic, you have the ability to define a TTL for that message. If that TTL then expires, that message will go into a dead letter queue, and that dead letter queue will hold messages that cannot be processed. You can then remove messages from that dead letter queue, and you can inspect them and see what's happening. It'll let you process them as normal. So if you had any error handling, you would point some of your error handling at a dead letter queue to look at messages that have got in there for whatever reason. But that is basically, if you think of messages and mail again, dead letter queue is basically where your undelivered reports go to, effectively. Okay, so scheduled delivery is another great feature, and scheduled delivery is actually fairly new in the past 12 months or so. So you can submit multiple messages or a single message to a queue or a topic for processing at a later time. So you can then schedule a job to become available for processing by a system at a specific time. So again, great example of this would be any kind of batch processing. Generally, organizations do batch processing on an evening out of hours. So what you then do is you would post your messages on throughout the day, and you would schedule a delivery for when that batch service is up and running. So thinking of how you might use Azure and the power of the cloud to do some clever things here, this service is not running 24/7 because we don't use it all the time. It only starts up at 11 p.m. at night. So we schedule a delivery of these messages for 11:15, for instance, once the service is started up and done any startup routines it needs to. and then those messages will then be sent at that specific time to that service. That's an example of using scheduled delivery. Okay, so message deferral. So again, deferral and scheduling seem pretty similar, but they do have different use cases. So when a queue or a subscription client can defer the retrieval of a message until a later time, that may happen because of special circumstances within the application. So for instance, if we have a batch processing system that retrieves messages, it may have a threshold. Once it reaches that threshold, it may defer subsequent messages until it has enough capacity to be able to then carry on processing those messages. So it's quite a nice way of not having to force errors back or force retries. It's a way of basically saying, yes, I do want your message, but I can't take it at a minute. If you think of when you're on your cell phone or your mobile phone, someone else calls you, they get a busy tone. It's effectively like having a busy tone on your application. It's like the message bus is saying, here you go, here's all of these messages, and your application's saying, hang on, I want them, but I can't take them at the minute, send them later on, and you will be able to defer them. So batching we've talked about a little bit, but this is client side. So in your receiving application, the client is responsible for batching against a queue or a topic, and it will delay sending them for a specific time period. So this is where it will wait so many seconds and then it will pull down. So instead of just receiving once every so many seconds, we might pull once a minute and pull down once a minute. And that will then pull down on however many messages have built up. Obviously, it's dependent on what's there. So we've talked about transactions quite a bit so far and how that works. So we'll move on. And that one, filtering and actions, we talked about a little bit when it comes to subscriptions. Okay, so subscriptions, like we were saying, are what can define messages. Or define which messages rather they want to receive from a topic. So your filters can be on specific properties. So for instance, you may have a system that generates alerts, and those alerts are messages that go onto a service bus. You may have a receiver at the other end that only looks for any messages that have the priority set to 1. So they process high importance messages. You may have something else that looks at priority 2 and priority 3 and so forth. Or you may look at the timestamp and do something with it, or another property. The way you compose a message bus is always in a key value pairs. So you can look at any key and create a filter based on any of the keys that you've created within that message. I've got some links at the end to some useful stuff to read up more on all of these things, but there are lots more advanced features around security and how you secure the architecture, which are a bit too much to go into in this session, but well worth a read. Okay, so I have a goal here around maximizing the throughput of a single queue. So let's have a look at this, and let's look at how we would optimize the performance in this scenario. So scenario is that we have a single queue. The number of senders and receivers is a fairly small number, but still there is one queue. So just like most things in Azure, that one queue can only process so much at a specific time. So some of the things we might do. So to increase the overall send rate into the queue, you could use multiple messaging factories to create senders. Right? A messaging factory is the SDK portion of the endpoint which creates the message to send. So a messaging factory is what the sender uses to compose the message and send it onto the service bus. So then for each sender, you can use asynchronous operations, or you can use multiple threads. Async would be better, but depending on your programming language, you may have to use threads. So if we're using .NET, we would use asynchronous wherever possible. Async's always better because we can apportion the weights without locking up the thread, and we can move on to do other things while we're waiting, those kind of things. So that is a great way. Even though we have a small number of senders, small number of receivers in one queue, we could effectively create multiple async operations to send multiple messages and wait for the response. Okay, to increase the overall receive rate, we can again do exactly the same on the other side. So multiple messaging factories that are responsible within the code to retrieve the messages off the service bus or off the queue in this instance. We can create multiple ones and again, use asynchronous or multi-threaded calls. If you are doing client-side batching, so although the tool doesn't, or the SDK doesn't mandate that you must use asynchronous, if you don't use asynchronous calls when you are doing client-side batching, I can guarantee you're giving yourself a long, hard day. Because it is a scenario that I can definitely attest to from experience you do not want to be in. You will experience lots of lockups as the batches happen, which may prevent other things from happening within the application. So if client-side batching is a must for you in your scenario, then please always use async operations to be able to batch those up. Set the batching interval to 50 milliseconds. Okay, so why do we do this? We reduce the number of protocol transmissions. So you remember I said there's a limit of 1,000 concurrently. If you set them to 50 milliseconds, they are intermediate within those. There are disconnects and reconnects. So that helps with the processing of that value, because what you don't want are things constantly connecting when they're running asynchronously and batching up all of your batch requests and hitting that limit. What you want to do is have the interval set so that it's a connect, disconnect, connect, disconnect. If you're using multiple senders, like we've talked about a bit further up, if that's something that you want to do, then increase that interval to 100 milliseconds. Okay, so batched store access. So this is a part of the service bus feature that effectively increases the overall rate at which messages can be written into the queue. So there is a default limit at which messages can be written into the queue. That's to protect the API from being overloaded effectively. You can increase that yourself. You don't have to contact Microsoft to do that, but there's obviously limits at which you can increase it to. So if you imagine it starts here at the default and it can go up to a certain gate, but no further, whatever you want in between there, you can configure that too. If you find that you are processing lots of messages in a small space of time, then increase this value, because it really will help process things a lot more quickly. The last thing you want, especially given messages on service buses could potentially be time limited, what you don't want is you do not want applications as receivers waiting for messages that are still waiting to be processed. Right? If that is a scenario that your application produces, then leaving the batch store access as disabled and not increasing the overall rate at which those messages can be processed is a bad design pattern on your implementation effectively. So if you need to do that and your application that sends demands that, make sure you enable that. Okay, so finally on this, set the prefetch count to 20 times the maximum processing rates of all receivers in a factory. So there is a set processing rate for each receiver within the messaging factory. So one of the links I've put on the end has this information in. I can't remember it off the top of the head. But when you're configuring up the receivers, you can set something called a prefetch count. So set that number to 20 times that maximum processing rate. It's obviously fairly easy to work out. You can then reduce the number of protocol transmissions again. So again, we're talking about that TCP limit that's on there. So reduce, setting that prefetch count ultimately then reduces that number of protocol transmissions that happen. So it's really important to consider and think about. Okay, so recovery and replication, right? Seems like a very simple diagram. It actually is a very simple diagram. It's very easy to set up. When we're talking about things like VMs in Azure and doing site recovery of VMs, there's a number of different things you have to do and get in place for it to be able to work properly and fail over, all that kind of stuff. Less so with platform as a service offerings. A lot of this is just automatic for you. Pretty much the same. So step one, you create your primary namespace. It has to be premium. You will only get replication and recovery services if it's a premium namespace. It is not supported on standard and basic. The price jump between standard to basic, basic to standard, and then standard up to premium is significant. So only use premium if you absolutely need to, I guess, is the key message there. But first, you would set up your premium namespace in your primary region. Secondly, you would go into your secondary region. So this is, say this was North and West Europe. You would set up your secondary premium namespace, and then in the primary, step 3, you would then go into the configuration options within the service bus config itself, and you would then do a step called initiate pairing. It actually says pairing in under geo redundancy. So you would go in and you would pick the secondary namespace that you want to create. So what is great then is you will then be assigned an alias. That alias is then what you use to access your namespace. So regardless of whatever region your namespace is running in, it will be accessed via that same alias. That alias is global. So instead of it being a namespace name, like it normally would be, you were assigned an alias, which will basically make that geo redundant. Okay, so when it comes to asynchronous performance and when it comes to high availability within Service Bus, there's a few different things, right? So first of all, I mentioned at the top about Azure dependencies, kind of inadvertently. So that was where I was talking about it basically being based on storage, right? So fundamentally, underneath the hood of all of this is Azure storage. So make sure that you are aware of the various different things that you are able to do when it comes to asynchronous and high availability performance. Okay, so excuse me, just got a frog in my frog in my throat. So there's a number of different things that you need to be aware of. So from a reliability perspective, okay, so there are several ways that you can handle message and entity issues. So entity being the endpoints, and there's a number of different guidelines that Microsoft publish where they talk to you about how to remediate those things. So first of all is when it comes to throttling of external systems on which Service Bus depends on, okay? So throttling obviously occurs from the number of interactions with storage and compute resources. So if you have a lot of flip-flopping and a lot of messaging, it's a very chatty application. If you have lots of throttling issues, then you are in a scenario where Service Bus is probably not the solution for you. Okay, what you need to be looking at is something like Event Grid or Stream Analytics or now Event Hubs. Okay, so bear those things in mind, right? Having it occasionally, like every so often, is not a problem. But if you have it once a day or a couple of times a day or a few times a week, then there's something with the architecture of your application. So we talked a bit about optimizing performance. Look at how you could optimize the performance of your application first. And then if it is still not fixed the problem, look to change the messaging architecture, because there is something within there's something that is saying that, hang on, a Service Bus cannot deal with the number of messages that you are trying to process. Okay, so obviously one of the things you have to be wary of, and we just talked about geo-replication, is failure of the service within the data center itself. So Microsoft talk about those kind of things as catastrophic failures, and it basically means that the service is completely unreachable for a few minutes or a few hours. It's generally a few minutes whenever it does happen. So just be wary of those things when it comes to it. Dependencies we talked about. Throttling we've touched on a little bit. So with Service Bus and throttling, that enables cooperative message rate management. Okay, so what does that mean basically? So each individual Service Bus node has many different entities, and all of those entities make demands on the system in terms of CPU, in terms of memory, storage, and other facets, right? So fundamentally, this is a shared service on a cloud platform, okay? So when any of those facets detect that the usage is exceeding any of the thresholds defined, Service Bus may generate and deny a specific request. So the calling application would receive a server busy exception, and then it will retry after 10 seconds. Right, the mitigation for this is that your code must be able to read and halt any retries for at least 10 seconds. So if you receive that service bus exception message, you need to think about that and think, right, I need to have my code effectively wait at least 10 seconds before trying again. And you need to keep doing that for a number of times that's acceptable before your code then drops the message and issues a warning to wherever it needs to send that exception to. Okay, so the code will then reduce the probability of throttling by enabling partitioning on that specific queue or topic, and partitioning is basically giving us separate spaces to be able to process those messages, so thus reducing the risk yet further. So subsystem failures, we've talked about a little bit. This is where any internal component stops working. The service itself is designed to pick those up and restart and migrate to other clusters, and it happens in milliseconds. However, be aware that you could send a request at the exact same millisecond or so that is unavailable, and you will receive a timeout exception or a messaging exception, depending on what it is that you're trying to do. So Service Bus contains the mitigation for the issue in the form of client retry logic. So if the Service Bus cannot communicate with the receiver to push to pull it down to, then Service Bus itself will automatically retry. However, from your perspective as an engineer building the receiver, building the sender, sorry, and make sure that your sender is able to pick up these issues and respond to them appropriately. Otherwise, you're going to be in a tricky situation potentially. Okay, so handling outages, right? So there's 3 specific things that are really key when it comes to this, and again, standard premium namespaces are a little bit different, and then full data center outages. So in premium, you have geo disaster recovery that we were just talking about, so replicating to another region. So that's a really easy way to mitigate against that risk. Although be aware that you're paying for 2 premium namespaces as part of that design. The premium SKU also supports availability zones as well. So for those that don't know, availability zones provide fault isolation tolerance within the same Azure region. So Service Bus would then manage 3 copies of the messaging store, so 1 primary and 2 secondary. And Service Bus will keep all 3 copies in sync for both data and management operations. If that primary copy fails, one of the secondary copies is automatically promoted to primary. And there is no perceived downtime with that operation. It's transient, it happens in the background. So if the application that is receiving or sending sees transient disconnects, the retry logic actually in the SDK will automatically reconnect to Service Bus. So this is really good, right? So from your perspective as writing applications on top of that, when you are using, or if you are using availability zones in a premium SKU, you don't need to think about all of these things. Either the SDK or the service itself just deals with it for you. Always be aware though that make sure that there's proper error handling in there, because you know, it's the sod's law there that there's always the case that something happens that your application doesn't process properly and you end up having a problem that you can't deal with. So you know, just good practice, I guess, is the key thing. So in standard, so there's a concept called active replication and passive replication. So active replication is where we use entities in both namespaces for every operation. So what you may have is you may have a primary standard namespace and a secondary premium namespace. Let's just say they're called primary and secondary. So the first copy would be sent to the primary entity and the second copy would be sent to the secondary entity. So the client receives messages from both queues. So the receiver would have to process the first copy and the second copy would be suppressed. So obviously this adds an overhead, but to suppress any duplicate messages, what you have to do is tag each message with a unique identifier. So both copies must then be tagged with the same identifier. So this is where we talked about GUIDs for the message ID. Assign the same GUID for the same message ID or a custom property, and then the receiver must then maintain a list of messages that it's already received. Using that scenario, yes, there are 2 copies being processed into 2 standard namespaces, but you get a level of high availability and protection if one's not available, because you will receive 2 copies. Bear in mind the overhead of managing that though. Okay, so geo-replication is how you protect against data center outages. So bear in mind that geo-replication is only available in premium, but excuse me, what you do need to do is, if you do this in standard, I'm just trying to think of the right terminology. I think it's called Azure Relay. So those endpoints allow services to relay messages between each other whenever there's a presence of an outage detected. So you can achieve geo-replication as a bit of a workaround, although it's not as reliable. And if you have enterprise class solutions in, I would definitely not rely on this if it's incredibly critical these messages get there. But you can have a service with 2 different relay endpoints in different namespaces. So the namespaces have to be in different data centers, and the endpoints have to have different names. So for instance, going back to our primary and secondary namespaces, again, you could have primary service and secondary service at the end of there as the actual service name. And then the service listens on both endpoints. The client can invoke either service via the endpoint. So the client will randomly pick one of the relays and send its request to the active endpoint. If the operation fails with an error code, it indicates that the relay endpoint is not available, and then it will automatically try. So at that point, the active and backup endpoint switch roles. This is maintained within the tool itself. You'd have to do this. So there's a way there to be able to do that, although it's not as reliable as the premium SKU. So yeah, bear that in mind. Okay, so I'm going to leave these up on the screen so that you can see them, but there's some useful links there, and I'll send the deck as well so it can be distributed, so you can take those down. So the top one talks about the restrictions and the messaging quotas that are in place. There's then one just that gives you a bit more of an overview. The next one is how to monitor Service Bus. So one of the things that you often get when developers are working with solutions like this and cloud-based, cloud-native technology is that they're not operations people. They don't care about monitoring. So this is really important because this gives you the ability to look at what's happening and say, right, we understand the performance of this. And then last but not least in there is some information about how using Azure AD you can authenticate calls to that Service Bus instance using managed instance, managed accounts, not managed instances, instead of using access signatures, which is the default level of communication between the 2 systems. So yeah. Does anyone have any questions?
Yeah, we have open now for questions, but for starters, I have at least 2 questions. The first one is basically the monitoring. It seems that there isn't much of attention to monitoring with Service Bus. For instance, if there is some kind of monitoring for debt lettering, if there is a consumption failure, or if it's not consumed, the message, is there some simple way to monitor debt lettering? The next question is the Service Bus Explorer. If you know that, yeah. For peeking into messages, it seems a little bit strange that Microsoft does not have it within their toolset in Azure. That is a question that I got from another guy.
Yeah.
So
Okay. So the easiest one is around the Explorer that lets you peek in. So that's basically to do with a protocol that it uses. So the protocol that it uses is actually going to be deprecated. So it uses Advanced Messaging Protocol, AMQP. That protocol has been deprecated for quite a while, and newer versions of .NET do not have that library even included. So if you look at some of the SDK samples that are out there to do with .NET Core, for instance, so newer versions, like the real new versions of .NET Core, .NET 4.7 onwards, any of the client libraries for things like Android and iOS and Xamarin, they do not include that protocol. This is not Microsoft. This is the Internet Engineering Task Force. So it's a protocol deprecation. This is why you can actually use that Service Bus Messaging Explorer to talk to any AGMP queuing based messaging bus. It doesn't have to be Azure Service Bus. Are they replicating that functionality anywhere into the portal? No, is the short answer. As to why, I honestly don't know. So I can't answer that one further. As for monitoring, though, so you're right. The monitoring is very light, right? So the only thing you can really monitor out the box is metrics in Service Bus. So looking at the third link I've posted, it will talk to you about how to look at the processing rate, how to look at the size of the queue, all that kind of stuff. But one of the things to bear in mind, right, is as with a lot of platform as a services, so think about SQL as well, like this as well. So SQL will tell you about slow queries, but it doesn't necessarily flag up that slow query is a problem in any monitoring solution, because that query might be designed to take 2 hours, right? You might not be able to make it any faster. Right? The point I'm trying to make there is, absolutely, the dead letter queue is important, and you do need to know what's in the dead letter queue. But Azure itself doesn't know whether stuff is meant to be there, not meant to be there, whether it's been put in there because the receiver's timed out, the sender's done something wrong with the message format or anything like that. So the easiest way to solve that is effectively to create your own Azure function that will peek into there and generate an alert in Azure Monitor whenever it's above an acceptable threshold.
Exactly.
That's the way
it's a kind of a strange that it's not out of the box from Microsoft. That's for monitoring specific things like that, even though they don't know if it's going to be there or not, if the messages should be there or not, it should be available. That's just.
I agree. Yeah, I agree. I mean, I can see why that functionality is not there from what we're talking about, but like you say, the ability for you to be able to say, well, if there's more than 5 in there, I want to know about it. It seems like something that should be quite straightforward to do. But yeah, that functionality is not in there. All I can suggest is going onto the Service Bus user voice site, and if there's an existing feature request for it, upvote it and give it some more votes. Or if it's not there, create a new feature request. As with a lot of the product teams, they're very respondent to a lot of stuff that's posted on there and do a lot of development based on what the community and the people that use the stuff day to day are telling them they need in the product. So if it's a particular pain point that you're struggling with, I would recommend going down that user voice route and posting up some specific feedback if it's not there already.
Well, we haven't any questions yet, so I think we should just have it like this. So yeah, is there anything add that you would like to
add? Not really. I think
is there a way to contact you on LinkedIn or something like that?
Yeah, so you can anyone can find me on LinkedIn. I'll put my in fact, what I'll do is I'll put my LinkedIn and my Twitter on the bottom of this slide before I send it to you, and feel free to distribute it out to people that have attended. That's fine.
Well, thank you,
yeah.
Martyn.
No
Thanks
problem.
for giving us the time to talk about this subject. I know that a lot of people are thinking about this, but they don't really know how to utilize this. So this clearly explains a lot. So thank you for that.
Yeah, no problem. Think the thing I would finish on, it's really is just, you know, think about the stuff I was talking about at the beginning, right? If you want to use it, then it's there, but it's quite a specific use case, right? There are other messaging tools within the whole suite. Okay, so think about what you're trying to use it for. Think about the number of messages that will go through it, how important it is that those messages are received either in a specific order or not a specific order, and you know, think about whether your primary goal is moving data on systems from A to B and then B to A if you do need to go back. Then Service Bus sounds like it might be something you need. Or if you are simply looking to ingest data from a system and send it somewhere else, then one of the event-based systems are more where you need to be looking.
Exactly. Well, thank you.
Right, no problem.
See you later.
Yeah, cheers everyone.
Bye-bye.
Bye.